And the last one is bitwise operators. Bitwise operators. Bitwise operators are applied on the bit level, that is in zeros and ones. That is the reason why I have just recalled you with the 0 and 1 notation. Actually, we need to pronounce it as true or false. But for bitwise operator, it will be very easier for understanding. That is the reason why I have represented 0, 0 as false, false. Okay. Now, coming to this particular bitwise operators, the different operators which fall under this bitwise operator category are, the first one is bitwise OR, that is, it is represented by single pipe sign. Next, bitwise AND, it is represented by single ampersand sign. Next, bitwise NOT, it is represented by tilde sign. It is represented by tilde sign. Next, we also have some exclusive OR. Exclusive OR. And next, we also have right shift and left shift. We have right shift and left shift. So these are all the different operators which comes under bitwise operators. So the table will be the same, but just we are going to say change with 0, 0 and once we are going to change. That is, for false we are going to put as 0, for true we are going to denote as 1, because it works with a bit level. Out of all this, the very important is the right shift and left shift. So in right shift, if you take a number, that is, if you consider a number as 8, the Boolean representation of the value 8 will be 1000. 1000. Now I am shifting one bit onto the right. That is 1000. If I move one bit right, then it will become 0100. Which means whenever we are performing right shift operation, the given number is divided by 2 to the power of n bits. The given number is divided by 2 to the power of n bits. Now the value of 1000 is 8. 8 divided by how many shifts? 1 shift, which means 2 to the power of 1. 8 by 2, what is the value? 4. The representation of 4 is 0100. You can see like 0100, we got it whenever we shift by right shift with 1 bit. Similarly, now the value of A here is 8, which means 1000. Now I am shifting with 2 bits. That is A greater than sign followed by 2. This is what we call it as right shift. Greater than sign, here it is right shift. Now 2 to the power of 2. What is 2 to the power of 2? 4. Now take the logic of this right shift. A number is divided by 2 to the power of number of shifts. 8 is divided by 2 to the power of number of shifts are 2. 2 to the power of 2 is 4. 8 by 4. Now the result is 2. So this is how the right shift operation works. The next one is left shift. Left shift is denoted by 2 less than signs, whereas right shift is represented by 2 greater than signs. Now let us take the example as A value is 2. 2 is denoted as 0010. Now if I am performing left shift, I am shifting the bits onto the left shift. A less than of 1 bit. A less than 1 bit. in the left shift, the logic behind the left shift is we need to multiply a given number by 2 to the power of number of shifts. Multiply the given number by 2 to the power of number of shifts. The number was 2 and it was represented by 0010. I am now left shifting with 1 bit, which means 0100. Right? Now the value 0100 is 4. We all know that. Now let us see with the logic how it works. The given number is 2. 2 into 2 to the power of number of shifts. The number of shifts in this case is 1. What is 2 into 2 to the power of 1? 2 to the power of 1 is 2. What is 2 into 2 is 4. We got the number 4 and we have got the representation as 4. So this is very, very important as part of interviews as well. What is the difference between right shift and left shift? In right shift, we divide the number by number of shifts. In the left shift, we multiply the given number by 2 to the power of number of shifts. So this is very, very important point which will be asked in the technical rounds by the interviewers. This is about the bitwise operators. Totally these 4 are coming under binary operators.